quick review of logarithmic and exponential expressions and kind of your first intro to dealing with logs. So the first couple problems just say to write the exponential form for the in exponential form, excuse me, for the following logs or natural logs. So I would again pause the video and see if you can do that. And I'm simply just going to write out the answers because there's not a whole lot of explanation. But the first one, log base 3 of 1/9 to the negative second. So your base of the log is 3, which means the base of your exponent is also 3. And then if you raise that to the negative second, you should get 1/9. And of course, mathematically that checks, so you know you have it in the right order. The second one, the natural log, remind yourself that when you have the natural log, there's a base of e, but you won't see that e base. You have to remember that. So the base is e of natural log, which means the base of your exponent will be e. So it will be e cubed equals 20.1, which it does. And the last one, again, a natural log, which has a base of e. So e raised to that 5 equals e to the 5th, and sure enough, e to the 5th equals e to the 5th. Then we're going to evaluate some logs. So again, pause the video and see if you can try these on your own. So log base 2 of 32. So you're really asking yourself 2 to the what equals 32, and of course that would be 5. So that's 5. Here you're saying 1/2 to the what equals 4. Well, 1/2 squared is a 4th, so you're going to have to raise it to the negative second so that it reciprocals. And natural log has a base of e, so e to the what equals e to the 7, and that would obviously have to be 7. And log, remind yourself, has a base of 10, so 10 to the what equals 1,000, and that would be 3. And then last but not least, graph a log, and you know what, I'm actually just going to toss in a -1 here to just make it a little more complex. I would remind you on your calculator, because logs are not easy to graph. So 84s, some of you have the base formula on your calculator, so if you go to math and go down to the bottom letter A, so like alpha A should say log base. If you have an 84 calculator and you don't see that, ask your teacher to update your calculator, your operating system, because that's a really nice feature. And what it does is it leaves a little blank for your base and for your x, and you just fill those in. So if you, but for the rest of you, like if you have an 83 or if you have an older model of an 89, when you type that into your calculator, you can use the change of base formula, which says take the log of whatever you're taking the log of, so in that case it's x, and divide it by the log of your base, and my base was 3. So that's your change of base formula, which is just another way to write this, but allow your calculator to evaluate it. And then it's -1. And do be careful, this -1 is not in parentheses, so it's not. If it were, it would be a part of this x right here, but it's not, so you just subtract 1. Now if you go to your calculator, and I'm going to do the same, and type that in, and we're going to look at it on your table feature, because I think at this point that would be a good thing to be able to do. So typing this into your y equals, and I'll give you a second to pause the video and do so. And then if you go to your, well, first of all, with logarithmic functions, graphs, excuse me, they're opposite of exponential graphs. So exponential graphs, note here that I have a vertical shift down 1, and I don't have any horizontal shift because that would be something in the parentheses with my log. Now normally your vertical shift is your asymptote, but that's with exponential functions. So now it's my horizontal shift that will be my my asymptote for logarithmic functions. And so I don't have a horizontal shift, hence my asymptote is x equals 0. Notice it's x equals and not y equals. Now you have vertical asymptotes. So some things to keep straight. And then if you go to your table, and I'm just going to write down some values that I get, you'll notice error messages for certain x values, which is fine because you can't evaluate, you know, like for example, any x values over here, you can't evaluate because they're on the wrong side of your asymptote. So if I just look at, like, I get 1, -1, I get 3, 0, I'm just kind of trying to pick out some nicer points. I get 9, 1. That makes sense. 1, 3, and 9 are all nice bases of 3. So if I do 1, -1, 3, 0, 9, 1 would be way out here. You get the idea, and your logarithmic graph looks like this. Now, when you graph this on your calculator, it looks like it kind of just starts right here and goes like that, but do understand that logarithmic graphs, like exponential, go on forever in both directions. It's just riding along that asymptote, so you can't, but if you trace on your calculator, it'll take you down there. And that is graphing logarithmic.